problemen op. Dus ik kan dit video gewoon als goed, we merken het wel. Ja. A small recap about yesterday. We had some questions yesterday, and I forgot them, but if we could try to address those today. Had you some concrete questions?
One question is what you did last lunch, the 10 commands you entered, with point D, with the ref test, and adding a block, BTC, adding the address. If we could have those 10 commands somewhere. Or just a small example how you started to debug blockchain.
Yeah, well, so the main one, you've got two main things.
Well, shall we first make an index of some questions? Then, Walter, do you have some concrete points?
Yeah, well,
Art, please remember your question.
I'll do the writing.
In the chat?
I also had, in this respect, some technical questions, just things that I'm not familiar with, I think, but it's like how much data can you actually store in a transaction? Yeah, because there's a lot of, I think, applications that are more about storing data, recording data on the blockchain, sort of time stamping. But how much data can you actually put there? And also in your code, you have all these opcodes or OT codes, I don't know how you call them, what are they all doing, and how many are there? Where can I find some of the details? Or?
Yeah,
please repeat the chat.
Could you repeat that? No, but I have some questions about storing data inside the transaction, or how does that work? What are the limitations? Should we do it?
That's a good one.
Should we not do it? And then there's also in this code you see all these opcodes or OP codes. I don't know how you opcodes. There seems to be a lot of them, but I'm not really sure what they all do.
You mean the scripting language?
Yeah, I don't know if it's part of the scripting language or whether it's part of the data structure. Or, I'm just not sure. What wrote them? Yeah.
Janus, do you have some?
That one about basic boost. Talk about it a little bit.
Basic boost.
Basic boost.
I think that's the biggest one.
David.
Would like to know something about the miner fees. That's calculated and how that works.
Okay.
Heb je die heen?
Yep.
In your own version?
I'll do the last.
Oh.
I can write.
Then let's do Michiel, otherwise we forget. Heb je concreet?
It's a little question in line of Walter's question. It's possible to store data in the blockchain without burning Bitcoin. Of course, you have a return, I guess, but it's possible without. Sure.
Roy?
I have a few questions, but I think one of them is didn't really make it work the question out yet, so it will come later.
So my own question is about, I would like to have more deterministic questions like you said yesterday. As an example, you said, why would we need global consensus? That's a very deterministic question if you you're analyzing all the possible implementations and the hype around it. I would like to know if there's more questions like that we can use as a filter over possible applications.
That's a good one.
By the way, I will keep trying to index questions during the day. So, if you got a favorite first one to cover.
Yeah, so in fact, I'll answer your question with the question, why do you want to store data?
Well, because I think the idea is that by storing the data, you have the properties that the blockchain provides, in the sense that it's timestamped, it's immutable, you can prove that it's there, but it's public. So, the way I see it now, it's public, but because from what I've seen, most people only store hashes. It's public but meaningless, because if you don't have the original content, you still don't know anything. So, but is that the best solution, or is that because of space limitations that people are putting only hashes and not some actual data, or is it for privacy reasons? Like, okay, we want to have it timestamped and public, but we don't want to have it public.
So maybe to clarify that, this is after all security software.
Mm-hmm.
So what are you trying to prevent from happening?
Well, I don't think it's, for me, it's so much about trying to prevent something from happening, but it's more being able to prove something at some point in time, that something, a certain content, certain information was recorded, was known.
I mean, again, we got to ask why. Like, what's the use case we're considering?
Well, I mean, I can.
I mean, there's lots of things we could do. I mean,
Yeah.
we could go put our data on a rocket ship and send it off to Pluto.
Yeah.
But, what are we trying to achieve by doing that?
Well, yeah, for me, they're trying to achieve that data is falsified afterwards by claiming that it existed, or by changing it, or and maybe to be a bit more clear. I mean, the application. I'm coming more from the industrial field, yeah? And there's a lot of information like certifications, calibration certificates, that someone has inspected something, and it's currently there's paper, there is a written certificate by some test institution that this material or this piece of equipment was safe, and that information is then stored for 20 or 30 years, and if there ever is an accident or anything, then you go to the, currently we have notified bodies, which are just third parties, trusted third parties, that store all this information, and then you go to them and you say, hey, whatever, there's an accident with this plane or with this whatever, and give me all the certification, let me check it, and then there's a lot of cases where fraud has occurred, like, okay, we didn't test it in time because the certificate expired. Oh, let's change the certificate, or let's to cover up the accident or the fraud. So
I mean, let's do a concrete example. I mean, let's suppose we have a plane and has a landing gear. I hope it has a landing gear.
Yeah.
And we want to know why the plane mysteriously only has one wheel on the landing gear rather than two. And presumably, we would go back to the certification inspection report and determine, well, who the heck signed off on a plane with one wheel rather than two?
Yeah. Or who checked? Who was the last person who checked that there were still two wheels? Yeah. And
so the security threat model is someone who's extremely embarrassed that they can't count the number of wheels on a plane, and they wish to go change the inspection report to remove their name and put someone else's name on it.
Yeah.
And that's a reasonable threat model. So, well, I mean, if these are cryptographic inspection reports, presumably they're signing that report with their key of some kind. I know maybe they have an employee ID card.
Could you put the...
maybe they have an employee ID card that has a key in it. And the obvious thing for them to do if they're rather embarrassed about their inability to count is to go steal their buddy's employee ID card and sign the thing with it. And if we timestamped this inspection report, we could go and reduce our opportunity to do so because the timestamps would be wrong. They would have mysteriously done the inspection after the plane crash rather than before.
But one of the problems is currently also, I think, that the information is not publicly available. Yeah. So if the whatever, there is this crash of Egypt Air now, Yeah, and the last inspection was probably done at Charles de Gaulle in Paris. But the authorities in Egypt, they can't get to that inspection report of that particular employee because they would have to send a request to the French authorities and say, give me the inspection report. Well, that's again, then you need to trust the French authorities to actually come up with it. Because maybe the employee did it, and maybe the employee didn't steal the car, but maybe the French government thinks, well, maybe it's better if we say that we did inspect
for
it.
planes alone, I mean, I wouldn't be surprised if we do worldwide on the order of like, 10 inspections per second or something.
Yeah.
So sounds like to me we need a bigger block size. Why don't we just make it infinite?
Yeah, but so
Because it is, I mean, I think we can agree that for the timestamp thing,
Mhm.
right? To go and timestamp the inspection reports, we would put stuff into a Merkle tree and that scales infinitely. Right? So that's not a big deal.
But apart from the scaling in the number of transactions, I mean, the way I currently understand things and see it, that there's very limited space for adding data. So people are ending up just putting hashes. So then, okay, there was some kind of inspection report, and then the hash of the inspection report is on the blockchain. But I cannot see the actual inspection report. But
On the other
what
hand, you
I'm
never
wondering
let
is why people are using hashes there, because, okay, there's very limited information, but you could probably still, I mean, the time is already by the transaction.
well,
so you
you
don't
can
need to
keep
store the
in mind,
time.
it's even worse than that. I mean, not too many people have implemented yet. I'm one of the people who has, but you wouldn't even necessarily store a hash in the blockchain. Right? You might go and timestamp the hash that in turn is a Merkle tree of like a million things. Right?
Mhm.
So that hash is completely meaningless if you have one of those things, because you need the whole path all the way up that tree to the hash that's actually timestamped.
Yeah, but you would have the data would be somewhere external.
Well, I guess my point is, if you lose any of that data, you're screwed. You can't.
Yeah.
On the other hand, if you lose the data anyway, I mean, the hash in the blockchain is meaningless too.
Yeah.
So
But you
it's
can't.
it's not a big deal to keep some, Merkle paths all the way up.
But I mean, instead of a hash, you could imagine that you just put at least some encoded information. Yeah, you could just put whatever a JSON object representing the name of the inspector and the name of the identification number of the plane. Yeah, even with a few bytes, you could actually put some information. But
This is the interesting thing. It's just a matter of, given that blockchain space seems to be limited. If it is more valuable for you to go put those few bytes in than it is for me to go put my few bytes in related to my inspection report, you can go outbid me and I'll get forced out of the market. I mean, I mean, in a network where you put stuff onto the network and every single person in the world participating has a copy of it, that's never going to scale very well.
But you could easily imagine some sort of torrent-like network that stores the data. And then we just go there, and there's some sort of common torrent-like network that
of course
retrieve the data from.
The question is, how many copies are there out there? Right?
Yeah.
In Bitcoin, the number of copies is equal to the number of participants, basically. Modular pruning and stuff,
But is it the real problem that most governments won't allow to share this internationally? Because I can imagine that the French government, for example, will never, by the way, the American also, they will never be willing. I mean, you can think of any international standing if you want, but they are effectively giving away their sovereignty.
Yeah, but I mean, I see what you're saying, and maybe with planes that might be a bit of a tricky example. But I mean, at the moment, the system exists for a lot of safety related information in industry is stored at a very limited number of trusted third parties. Yeah, so the governments have they're not even involved in that because it's not even their regulation. Well, in some cases there is EC directives stating which data you need to store at a third party. They don't specify which. It's not a government. Yeah, you have these organizations like Bureau Veritas and all these people who are storing this information for a long time. But so that is not controlled by government, and the information is industry information, and you in a lot of cases you even have to have it publicly. Yeah, I mean every equipment that has a CE marking, there is a certificate behind it and there is data behind it, and that data is actually supposed to be public. I mean, you might have a CE marking on your laptop with a number where it was deposited. There's no way you can go and verify it as a consumer. And you see already some nothing to do with blockchain, but you see some applications, especially in the developing countries regarding pharmaceuticals. Yeah, so that you can very easily type in some code on an SMS and you get a response whether this is a genuine medicine or whether.
I mean, I think we can generalize all this to say basically there are people with incentives to go and have data in a place that's very widely replicated.
Yeah.
But wide replication has problems because it's just really expensive.
Mm-hmm.
And I mean, as long as, like for some applications, yeah, they'll be able to go pay the price of wide replication, but it's probably not realistic to have like every vial of aspirin have a blockchain record of its inspection report.
This is also where do you put the limits for the amount of data you can store? There's a limit now, of course, but if you scaled up to X MB, where
I mean, fundamentally, like there's X amount of storage space in the entire world, and the more stuff you go put on that with higher replication factor, that's the less you can go store. I mean, that's kind of your trade-offs.
Yeah. Okay, the information is not currently stored centrally, so there's. Let's say there might be 2 or 3 copies of it. For security reasons.
Think this way. I mean, if we went and changed the laws and said, well, if you can't cough up your inspection report, you just go to jail and that's that.
Mm-hmm.
I mean, that'd be a pretty good solution.
Some areas it's already like that. In some areas it's already like that. So.
Yeah.
But the only thing is, whatever, and then someone hands in a report, and then you cannot verify that it was the actual report.
Well, but we can timestamp. I mean, timestamping is easy.
Yeah.
Right. That's not a hard problem. So you can imagine, for instance, the rule was, well, you better go cough up your inspection report with timestamp saying it's before that time, or we just know, or we have good reason to think you never did it, which is illegal. We'll throw you in jail.
Yeah. So you mean that they only have to come up with something if the plane crashes, so that way people keep the organizations keep as much as possible their own sovereignty. Yeah. But if you can,
do some random inspections like they currently do anyway. Go pick some random planes and tell them, all right, go produce inspection reports for this. I mean, I think this sounds like people want it to be a blockchain problem, right? In the sense that they want this magical database that has unlimited capacity, but that doesn't exist. So
it's also the question how big blocks become if you store a lot of data on it, like 12 gigabyte blocks. It's not going to propagate properly to the network currently, so it's not going to work.
Now, granted, the other thing we can go do is say, well, we could create a blockchain of the inspection reports, right? Because so here's the interesting thing. With this timestamping threat model, can you think of a way that I can still fake inspection?
I mean, faking the inspection is still possible in a large number of ways. Yeah.
First of all, let's come up with a concrete one that makes the timestamp real.
Make 100 different versions.
Yeah. One of the biggest issues in the current situation is that there is an inspection report, but there never was an inspection. Yeah. Because we can write a report and say, I checked those wheels and those tires are still there.
I mean, in general, how do you prevent that?
Well, one of the ideas that people are currently working on is mixing those kind of things with beacon technology and things like that, so that you at least have to be physically present at the location. That still doesn't mean that you inspected the tires, but at least I can prove that you were close to the plane when you filed the report.
And so that's basically like a piece of trusted hardware.
Which sort of records that the actual guy certifying that those wheels were there was actually in the vicinity of the wheels, and not that he was sitting behind.
Which makes it pretty damning when he miscounted the number.
Instead of him just writing a report from his desk that, I just did Egypt error, most tires are still there. Let me timestamp the report.
Well, you can create 3 reports, one with 1 wheel, 1 with 2 wheels, and 1 with 3 wheels. And then
so first one, the wheels are like this. One we have 1 wheel. Another one we have 2 wheels on the side and 1 in the front.
What I actually found very funny to see is that the security of buildings is done, at every window there are magnets.
Yeah.
And the security people have to walk several times a night. And it's all being recorded, of course. So if afterwards there was some break-in at the window, which the guy says that he checked, then it's pretty clear that he was sleeping or whatever.
Yeah. You should not make it. Use little RFID tags to be exact.
Sure.
Right, they're little RFID tags. Right, so you go tag in,
Yeah.
and there's a secret key in the RFID tag.
Mhm.
Or, I mean, the really dumb versions are they just have like a little paper log that you're supposed to sign. But this is good security stuff. It's a little RFID tag.
Yeah.
My mom used to
I
be
was
security
actually
guard.
surprised by, because I was thinking about it and I thought, that's actually a very good model to check if someone does what he promises to do.
Yeah, but
Proof of
every,
presence.
But the result is that you have really a lot of tanks.
Yeah.
Because they really have to walk everywhere.
Yeah.
yeah, but
Yeah,
every,
they also do Bluetooth for all this stuff.
Yeah, you often see them on buildings, like little round dots.
Yeah.
And you're actually just go up and hold up a reader to them.
Large antenna.
no, but that's, I mean, it's not so much blockchain related, but those things are being done, yeah. In the cleaning industry, they're starting with it. Because we all know the paper looks on the back door of the toilet door where someone has signed that he was there at 10 o'clock. But he could also come in at 12 o'clock and sign for 2 times, and they need to send inspectors to verify that. It's much easier to just have a tag and a smartphone.
So here's the
prove that you were
interesting
there.
thing. So if our model is we go around with our employee ID card and we use it to go sign off on our inspections or whatever, I mean, we still have the threat of theft. So if I'm an honest employee, right? Can you think of a way where we could design a system with a blockchain where I would go know if someone has been stealing my employee ID card and using it on my behalf?
Well, you should be able to see transactions that were signed with your card, that at a time or whatever when you were not working or not doing anything.
Right. So I think I mentioned this before. Like, so blockchain has one aspect, which is the boring bit of timestamping. The other aspect is you can go and determine the set of all possible messages, right? And so for some purpose. So you can imagine if you went and had a blockchain per employee, where every message where they were supposed to go sign off, be it, I inspected the plane's wheels, I inspected their engine, whatever, was in like one place. And now when I go check that log, all right, did anyone else go and sign any messages on my behalf? I just go search through the records and, that's funny. I was on vacation, yet my badge was used 10 times. And granted, you just do this with database too.
Yeah.
But you could come up with a model where that's a bit more provable.
Oh, but you can do a lot of those things with a database. The problem is you have to trust the person who controls the database, that he doesn't make any changes.
Well, so concretely, how would the database administrator go and cover up that kind of lie?
If you design a database such that it has hash sort of like a blockchain, you can hash the data.
Well, I don't know. Say, how would the database administrator go and, like, specifically, how would that database administrator collude with the guy taking inspection reports to cover up that lie? Right. So let's say Alice is an honest employee, Bob is a dishonest employee.
Just a normal flat database, you mean?
Yeah. I mean, how would Bob prevent Alice from learning that he stole her ID card and was signing off on her inspection reports?
Change some.
No, you're missing my point. You're trying to solve the problem. I'm saying, how would that fraud actually happen? Like, let's not solve the problem first. Let's figure out how to make it.
I mean, the administrator can delete some records and then change them.
But if he deletes records and, the safety inspectors come in, I mean, they would notice, wouldn't they?
Well, it depends on how the database is designed.
Okay. So we assume we have some safety inspectors, and they come in periodically and check the records for consistency. How are they going to see apparently real records of Alice signing off on inspection reports, yet we're going to prevent Alice from finding out that her card's stolen?
That's going to be tricky, I guess.
Well, I mean, if we can't perpetrate that fraud, I mean, then maybe we don't need to solve the problem with blockchain.
Yeah.
You know, we can't just blindly apply blockchain to this. We got to figure out, well, what type of problem are we solving?
If you have the procedures and the database designed well enough that you can't really do much, and you add some timestamps from the books, maybe
For me, I think one of the points is where you're saying that, okay, you need to have some inspector that periodically comes around to check that things are still correct. Yeah, and that kind of inspector, I think you want to get rid of you. Yeah, you want to get rid of that by using technology.
Well, hang on, so let's be clear. So we have Ivan's our inspector, right?
Mm-hmm.
He comes along periodically and queries the database and checks if, you know, the records are correct,
Mm-hmm.
right? And he'll go check, well, did the inspection reports get signed off properly, and so on and so forth. Alice is trying to prevent her card
Mm-hmm.
from being fraudulently used to sign inspection reports that she didn't actually authorize. You know, because these are fraudulent reports, she doesn't want her name attached. And we have a database admin who's in cahoots with our malicious Bob figure who's busy off trying to go fake reports, you know, to get the planes in there, even though he's never actually checked if the wheels are still on.
No, because there you have the problem that, I mean, most likely Alice cannot directly query the database.
Okay.
Yeah, so she needs to rely on some report produced by some system admin to give her the results of like when did
All right, so let's fix this problem. Let's give her access to the database directly.
And then it's easier to look at your own transaction and maybe match them with your timesheet when you were working and say, hey, on this day I was not working and my
Well, I mean, it sounds like we solved the problem already. All we had to do is just give Alice the ability to query the database.
Yeah.
All right, sounds like we don't need blockchain.
Well, for me, you need a blockchain in that case because the blockchain is inherently public, so it's not just Alice.
No, but hang on. Let's concretely figure out how is this fraud going to happen.
No, but then you say you give Alice access to the database. Yeah, fine. But that's still within maybe the boundaries of an organization. And now,
but I mean, Alice is the one who cares about her employees.
Yeah. But if in other applications, there might be a lot of people who care about.
Well, I mean, so hang on. So are you arguing that we solved the problem in our case? Yeah. All we wanted to do was prevent Alice from, you know, having her ID card stolen, and apparently we have by just giving her access.
Yeah.
Now, can you think of a way where the database admin could go and still lie to Alice? Like, you know, what if, for instance, he knows on what days the inspectors are going to come in?
Yeah, just change a few seconds and then afterwards change it back again.
Happens all the time. Right? So what you're saying is that our database admin, whenever he sees an inspector come in the door, he types in a few commands, changes the database, and then when they go leave, types in a few more commands, and all the records mysteriously don't have Alice signing off anymore.
You can do the inspection in 2 persons.
All right, so if you're going to propose a blockchain solution, how exactly will that fix that problem?
You start doing your own proof of work inside.
No, but you solve the problem because you cannot make those easy changes. Yeah?
All right, but why can't you make those easy changes?
Because you cannot change transactions that are already stored.
But why?
It's distributed.
Well, you can fix it by just share the database with all the other organizations that support the system. Each airport has its own copy of the inspection system you run. So you need to convince the entire world with all the airports that if you want to make a change, that they also need to make a change. Otherwise, if you run the database, you can just
sounds kind of inefficient. I mean, now everyone has all this data carting around. Plus, also, I mean, maybe I don't want my competitors to learn stuff about how often my planes are broken.
So you hash the whole that database, put it in the blockchain, and then communicate it to the inspector. So this is the current state.
Okay. Well, what I'll do then is I'm going to go and me, the evil administrator, I'm going to go and hash two different copies.
Yeah, of course.
How are we going to prevent that? Like, how does Alice know that when she looks at the database, it's different than when the inspectors look at the database?
It's the solution David, so more people have to be there to sign off the inspection report. So, that's not cool.
I don't know, it sounds like a lot of money's being spent.
Yeah.
Is this blockchain supposed to save us money?
Yeah.
I'm not sure if blockchain is supposed to save us money. It can provide information that we currently don't have in a reliable way.
Well, I mean, better go save
I mean,
money,
you're
or
right.
how am I going to charge $300 an hour? The more money it saves, the more money my clients can pay me.
No, but it's, I mean, the remark is also made, yeah, maybe as an airline, you don't want that information public because you don't want your competitors to know how many plane or failed inspections you might have had. But as a person flying, I would like to know which airline has most security incidents or things like that. So there is the information has a lot of value, and that information might be quite expensive with a blockchain to make available. Maybe, but at the moment,
But can we like get the best of both worlds? Like, I mean, we have a very simple problem apparently. We just want to make sure that when Alice queries the database, she gets the same results when the safety inspectors do.
Mhm.
Seems like a simple problem. Then we know that we can go take the state of the database and hash it up, right? And that hash, I mean, if Alice figured out that that hash was different than the hash when the inspectors were looking, she would know that there's something very wrong.
Alice should keep the records herself.
Well,
She signs off and keep at least the hash.
Yeah, I mean, she can easily keep, her reports. I mean, we already showed how with Merkle trees, we can go and identify something within the tree, even if for the rest of the data is discarded. Right? Like when I go, if I were Alice, when I went and signed my report, I could go get a receipt from the database saying, yes, your report's in the system. And go back up to the root hash of the system. And you can verify that from that state, my report's still in there. And then all we need to do is make some way for Alice to go and compare notes with the inspectors to determine if they're looking at the same database. And since she's probably not going to talk to them directly, well, why don't we just go publish the hash of that on, say, the company's website and sign it with some well-known pub key, right? So they're making the claim very publicly. The state of our safety report database is this. And anyone can go get that information, right? Because you don't need to be authorized to get the state. You need to be authorized to get the information committed to the state, but not the state itself. And now anyone can just go to the website, get a signed copy of that state, and compare notes with other people.
And the state is the whole Merkle tree or just the root?
The root of the Merkle tree, right? It's commitment to the state.
Yeah. So you're saying that if each inspector employee just makes a state hash each day after they sign out and go to their homes, they can a system admin can just say, oh no, this was the latest version, and he changed it back, right? But if all the employees say this is the latest version.
Good. We have evil and good database. Nice. So we have the good database, and we can imagine it having some tree. We have Alice's check mark. It's fully official, signed inspection report with 2 wheels. And she could go and check that some very public root hash goes back to per report. Specifically, I mean, we can go and have a tree that's indexed by, say, employee, right? So you can say, all right, starting from here, give me all reports by Alice, go way down the tree, and then that can be just a big list of some big set of reports. And then if someone's going to go fake this, well, what they want to do is create another data structure. At the bottom has a fake report saying the plane had 3 wheels. Because apparently the planes are supposed to have 3 wheels now. We should make that. Alice honestly says that the plane seems to have only 1 wheel, and therefore failed inspection. For the fake report, is the plane has 2 wheels, and it's passed inspection. And Alice wants to be sure that her failed inspection report actually ends up in the database and not something else under her name. So if we take this state of the entire system and we publish this on the website, right? So everything after this point is public. We publish that on the website, you can sign it on the website. Well, now that Clark's database admin has a big problem, because he needs simultaneously say this, while also saying this to Alice. And if both of those publications are very public, I mean, they're going to get detected. Alice can just go to the website at her home computer, which the database admin has no ability to compromise. And she'll see immediately, hang on a second, inspection reports database says this, when in fact it should say that.
But then you could compromise the website.
You could, but the problem is the safety inspectors will say, hang on a second, why the hell is it saying that the database hash is that? Give me a copy of that database and tell me, well, what are the inspection reports, right? Because the problem is, to commit fraud in this case, you're trying to say 2 different things to 2 different people. And if you can force the system to say the same, to essentially make public statements about the state of the system, you now can't commit that fraud, right? I mean, it's kind of like this case of, when you go buy a house. Both possible deed titles are valid in the sense that, there's a valid signature, it's a real house. It's just the fact that there's 2 different ones is a problem. In the moment you can find a way to compare notes and find the person who was also sold the same house, that's when you detect fraud. Right? But both these inspection reports are valid. One says the plane should be grounded, one says the plane should be allowed to fly. The only fraud is the fact that there's 2 different ones. I don't know, maybe the plane has 3 wheels and either is actually correct, but we just want to go find out that there's inconsistency.
But and instead of here you have fraud by changing it, but you also have a lot of fraud by just omitting it. Sure. Then the report that you said one is just somehow disappeared. Yeah. But then you also have a different tree. So
well, I mean, if the inspection report doesn't exist, someone will also notice it when they start asking questions. Yeah. Well, can you go provide the inspection report saying the plane was allowed to fly?
But you need to provide that inspection report to make the hash to verify the hash.
Well, think of it this way. I mean, if nobody checks these reports, no amount of database is going to save anything. I mean, if nobody checks when a plane is allowed to fly.
No, but you cannot leave it out. Yeah? So if someone is requesting information from you,
oh, sure, yeah. I guess my point is that the tech by itself is not magic.
No.
Right? Nothing will go and prevent a plane from flying with 1 wheel unless somebody actually checks those kind of reports.
No, but we currently have a lot of regulatory bodies checking things, and at the moment a lot of that is done by requesting information from the organization, and then they get the information and they check that, but they can't verify that the information is complete and has not been altered. Yeah, and I mean even recently I think there was a whole department of a hospital closed in Holland because it turned out that a lot of the incidents that they had were never reported.
Yeah,
the reports were made, and they were available internally, but they were never sent to the regulating body.
Well, I mean,
to verify
look
that.
at it this way. I mean, in this example, if nobody who's honest works at the works at the plane company,
Yeah.
no amount of tech is gonna
Okay, but
change that fact.
in I think in practice, it's usually not the inspectors that are not on, it's the, let's say, the management of the airline is dishonest when they're getting requests for safety data.
So what's interesting about this is, what we've actually done is we've designed a system where the people signing off on inspection reports actually have a duty to go and audit the company.
Yeah.
They have the ability to as well, which they currently didn't. But if Alice never bothers checking, like, that her inspection reports are part of this public,
No, but even if it's not Alice, but even if it's an external party checking, at least they can prove that some inspection report, in this case, the inspection report by Alice, was never provided to them.
But
like, hey, we're missing. You don't know that it's an inspection report.
Well, hang on. So let's be precise with this. So if Alice only ever writes reports and submits them, right? Yeah. She never once ever checks if reports are included in the public commitments.
Then you've been
problem.
Yeah, I mean, she will never contribute. The people who are busy off fraudulently omitting reports, she'll never find that out, and they'll get away with it.
Yeah. But yeah, so she needs to. Whenever she submits it, she gets some kind of transaction ID. And then you would have to look up once in a while that the transaction IDs are actually in the blockchain.
Yeah, I mean, this is actually this is actually a very serious problem. Because how the heck is Alice going to do this? I mean, she probably knows nothing but computers. Mm-hmm. She's a plane mechanic. That's her expertise. Not busy off checking cryptographic commitments.
And you're also saying if each employee of that airline submit their state hashes to a third party, to a third party that is going to check that. The only thing the management of that airline needs to do is go to the third party and say, hey.
Well, so I mean, let's suppose Alice has some device given to her by her employee, right, to go submit these reports. Which is probably how it's going to work, right? That device, she's trusting that device to go and submit the reports properly. Yeah. And if that device was like backdoored by the evil management of the company to never actually submit reports, she's never going to find out.
Yeah, right.
But so the only thing we can actually do is tell her, for instance, she could say, call up some safety inspection board and say, hang on, could you check for me that the records say that I went and signed off on this plane's failed inspection report? Because I don't, I, Alice, don't have the technical expertise to do this, but I can go to someone who I trust to do it for me. That's probably the model we're going to end up with.
Yeah, but that's what I said, that then they only need to corrupt one organization. Right?
Yeah,
not each employee.
Yeah, but that's why the ideas are to put some of this on the public blockchain, and you should be able to make it fairly easy for Alice to type in a transaction ID in a anywhere, because whatever software you use or website, whatever, they all go to the same blockchain database to check if that.
But I think we've already established that blockchains are never going to scale well enough to do this.
Well, they don't.
I mean, whereas I think I've actually got a very good model here. I mean, we have a well-known public oversight board that checks up on companies claiming to do plane inspections. Alice doesn't need to know anything about computers. All she needs to do is have a phone now. Every once in a while, say, hey, can you check some records for me? And yet, all this data, it's completely reasonable for it to be entirely private, right? Other than the very top level state hashes, which could be just published on a website.
So Alice is probably not allowed to take home reports.
Doesn't matter. All she has to do is knock down the, her name, the plane's tail number. Or I mean, it would be enough for her to say, hey, I failed the plane's inspection yesterday. Yeah, just check if you had a record of it.
Yeah, of course, they also come to Alice if her name is on the fraudulent report after the airplane tried to land with one wheel.
Yeah.
And Alice will say, oh no, I have a complete record here down in my basement. I upload each day if I have to.
Well, I mean, the hard thing for Alice is basically, well, someone's, some encrypted min goes and steals her credentials.
Yeah.
We can't assume she has any good ability to deal with that. I mean, we'd much rather design a system where even someone with zero cryptographic expertise and zero understanding how this works can still participate.
But isn't that a better solution? What I said, just have a copy of that database, and if that copy doesn't, is the same as all the other airlines in the world, it doesn't is correct, then
Well, I mean,
the whole world will say, what the fuck did you do? You corrupted the data. Of course, it's
I
not,
mean,
it's not
yeah,
really efficient.
yeah,
I know.
it's not efficient. It's probably not realistic. I mean, it would be quite reasonable for a company to say, well, why should we tell our competitors the specific times when we have a plane have to get grounded?
No,
Like that could actually be a very bad incentive, because it may be that, well, now I want to, I may be, if I'm running a plane, if I'm running an airport or whatever, I may have very strong incentives now to go fudge an inspection report just to avoid telling my competitors about information that's competitively relevant, even if there's no safety issue. I mean, planes get grounded all the time from mechanical faults. It's not a big deal, as long as it gets caught and appropriately dealt with. Doesn't mean I want to go tell my competitors every time.
Well,
Yeah, so you're saying you're making a copy that you send to the other airlines, and you also keep the foreign copy for yourself, and then
you might
goes wrong, you said.
Yeah, or it's like this kind of model. I mean, you can have a system where the data can be private, yet we can still audit.
Okay, but I mean, I understand that you say that the airline or whatever doesn't want that. Yeah, but that's also the same in the current situation. The point is that at the moment we're trying to force these airlines to make this publicly available.
I mean, that isn't necessarily, the point is that isn't necessarily something that's feasible. Right?
Yeah.
If we could get away with forcing them to just make everything available, we would. But that doesn't seem to be feasible.
Well, we are forcing them to make it
But
available.
also the problem is that you are forcing them to, you are creating incentive for them to do less security. Because you are forcing them to release privacy, to release competitive information.
Yeah, but but the whole point is, this is what we are doing. Yeah. Every airline has to report all their safety incidents to IATA. Yeah, and it is public.
Yeah, okay, but then they keep at the IATA also.
Well, but they publish the records.
hang on,
How many
let's-
incidents? How many?
Let's give a different example. What we're talking about is just accounting reports. I mean, will you accept that a company should have some financial privacy? Like, do they need to go report every single little transaction they ever do?
Some should, maybe.
Well, I mean, should all companies do this?
Maybe not. Yeah. But
So, I mean, you accept that you accept that not everything should be public.
no, but
So then how the heck
But for
would we-
some for some industries or for some applications,
Yeah,
yes,
well-
it should be.
All right, but
Yeah,
what,
if there's
all right, so
public-
we'll accept that some should, but what about the ones that shouldn't?
Yeah, once it shouldn't, they don't need to blockchain. There's probably also no interest in it. Yeah,
I
I
mean,
don't.
maybe.
Is
Well,
there any?
hang on, I mean, the Bitcoin exchange is a good example, where, if I run a Bitcoin exchange, I probably want to be able to prove that I actually have Bitcoins on hand to cover customer deposits. Yet, I don't want to go and have to give away the number of Bitcoins I have on hand. I don't want to have to give away who owns what Bitcoins. I mean, that's all very
Yeah,
sensitive
but
information.
to go a bit more into the examples that we had, I mean, there might be fire extinguishers in this building. Yeah, I'm not particularly interested in publicly to know that someone has checked the fire extinguisher at Krypton, because I don't work there, I don't care about it. But in other industries like airlines or some
Yeah, but
applications, they have a public
but the industry,
safety
but
interest.
hey, I'm not arguing that may not be the case, but for the industries where the public safety interest doesn't demand that absolutely everything be public.
No.
And in many cases, that kind of public safety interest will actually make things less safe. If I'm a bank and I'm forced to reveal every transaction, I will make things a lot less safe for people, because now people say, hang on a second, turns out you recently, got a big inheritance. Maybe we'll go, kidnap your daughter and hold you for ransom.
Mhm.
And as an example, in this Islamic State gained, a lot of territory. A big part of the reason why they did this was every new town that they invaded, They went to the banks, got the financial records, and figured out who they target next.
Yeah, but I mean, just to give
Like that very directly
Yeah, I
was
see it.
terrorists using a lack of financial privacy to further their aims of
No,
terrorizing people.
I agree with what you're saying, and financial privacy, yeah, in a lot of cases, there probably has to be, and because there is maybe also not a lot of interest for people to know, yeah, you can keep it private, because why should it be public? But there is also a lot of situations where you want it to be
But
public.
I'm not saying there aren't, I'm just saying that because there are a lot of situations where privacy is important,
Yeah.
we need to go find ways to go and, balance those goals of having good auditability, yet having good privacy.
Yeah.
Yeah,
But
like as an example, I mean, well, you may go say that plane inspection records should be totally public.
Yeah.
If I'm some terrorist trying to go and put a bomb on a plane, I can probably learn a lot about exactly what planes are where
Yeah.
to figure out, well, how am I going to sneak into the hangar and
Yeah.
get my bomb on the plane without getting caught?
Yeah.
If I have full information that's up to date of where planes are, what the inspection patterns are, I can probably think, hang on a second, nobody seems to do inspections, at 3 a.m. to 6 a.m. It sounds like maybe the shift starts. There's no one on shift. That's probably the best time I'm going to sneak in the hangar.
But that's a risk you always have, because a lot of this information is.
But it's a much bigger risk of getting more information out there. I mean, what a lot of security stuff is based on your adversary not knowing when your guards are on duty. It's just not practical to have people on duty 100% of the time. It just costs too much money, so instead we randomize patrols and stuff. Yet the information you need to determine if the patrols were done honestly is the same information you need to go and figure out, when you should go show up.
That's actually, we use a groupware solution. And the problem with that is that it makes communication too transparent for a lot of people.
Yeah.
So some old nerd friend of mine who doesn't want me to know that he logged in or something, I don't really understand his reasoning, but he logs in, synchronizes, logs out.
Yeah.
Because he's afraid that I could chat to him straight away. And that is kind of like, I mean, because nobody knows about this groupware solution for a lot of reasons. But one of the reasons is that it is too transparent.
Yeah.
That you can see that someone at 3 o'clock in the night wrote something. And I mean, if you're an employer that would say something about your employee or not.
Yeah. And, like as an example, I mean, people fleeing domestic violence, it's very common for them to have the partner, who's committing the violence, go and make use of information from social media and so on to figure out where someone is and use that to attack them and stalk them. I mean, heck, even when we had our Bitcoin Core dev meetup in Zurich a few days ago, a lot of people didn't really want that information that we were having that meeting to be public until afterwards. Because you have a whole bunch of people in one place that are involved in security sensitive stuff. I mean, that's a perfect target. Much better off to keep that information as private as possible until after the event has happened and it's no longer a threat. I mean, as an example too, I mean, if, fortunately, I don't think that's the case, but if, anyone attending that meeting had, was in an abusive relationship, that'd be a perfect way to go find the person and stalk them. They know where they'll be at this time. I mean, my travel is pretty public, which is annoying, but a lot of people don't have to make that trade-off. Me personally, like I've had my home address put on the Bitcoin development mailing list, basically as a threat, get out of Bitcoin development. Well, it's pretty public that I'm here and not at my house. If you want to break into my house, it's probably a good time to do it. I'm taking a risk by.
So you have viewers that is now watching you.
Yeah, well.
Please wait.
Yeah. Well, this I have a security camera in my apartment.
Yeah,
Okay.
you're right. I mean,
Yeah. But
That's standard examples that happen every summer at the airport. People are recording the labels on the suitcase that people put on the suitcase where they live. These guys are on holiday now. Probably for their big suitcases, so it's probably the next 2 weeks.
And you know, it's an interesting thing when you look at like law enforcement, how so much of the pressure seems to be to get rid of all privacy, but they don't incur the cost when something gets stopped. It's not their problem. You know, if you go and like have the FBI demanding that nobody gets encryption, well, one of the biggest sources of domestic abuse is law enforcement. You know, because they often have
sources of abuse.
Oh yeah, it's like rates of domestic partner abuse in law enforcement are very high.
And you mean policemen beating up people, or?
Well, you know, people who are in law enforcement abusing their partners.
Oh yeah.
Right, and that's a very high rate.
Yeah.
And one of the reasons why it's so high is because they have access to the databases to stop people.
Yeah, I heard that the people at the NSA were constantly checking their girlfriends. And you know what the problem is?
So they probably don't have
if I don't have a laptop, in the Netherlands, everyone who is a nurse has access to all the health information of every Dutch guy or girl. I mean, I also would have problems not looking up because you know there's so much information waiting for you. So that's the whole point, because people, when I say this, people often say, "Oh, you're a bad guy." Then I think you just shouldn't give. Je moet mensen niet aan die verleiding blootstellen, zeg maar. You shouldn't tempt people.
To the seduction.
Yeah.
Translate.
Oh, well, it's good. It seems like we actually have a reason to use a blockchain.
Well, the only thing about blockchain here is the timestamping, right? So those,
Well, I mean, remember, the timestamping was important in this application, but also being able to get to commit to a complete record. Now, I didn't actually show a chain in here, but the way you'd actually do this is every state, right, when you added new records, would be another chain, you know, would be another, like, you can think of this as a commitment, right, in a chain, and every state's another part of the chain. So if I want to know, like if I have this commit hash, and I want to know, is that one of the valid ones? Well, I just ask, right, prove to me that that commit hash was in the chain that you are now committing to the public.
but that's sort of like a private chain.
Yeah, exactly. Yeah. So, you know, you might have another honest record, so on, and then that commits to that state and that state and so on. And what's nice is just from that, even though all the data is private, we can at least determine that the data, that the right people who have authorization to access the data will get that data.
The only thing that the blockchain, the Bitcoin blockchain still doesn't here is timestamping if necessary.
Well, I mean, it's an interesting thing. Like, you could imagine a system like this where these top-level hashes are only published on the relevant company's website. Certificate transparency works kind of like this, where you have a certificate transparency server that everyone has access to. It's just a public server. They can just query and it spits back state hashes. It commits to, rather than inspection reports, commits to certificates that have been issued. And if you want, you can use that server to then get, the way it's implemented is, you know, get a full copy of all the certificates issued by an authority. None of this ever ends up in a blockchain, but seems to be sufficiently public that the system works pretty well. And that's deployed by like 30% of web browsers, because Google's Chrome browser supports it. So, and that's arguably, I'd say, the biggest public so-called blockchain technology in existence, where 1 out of 3 web browsers use it.
Yeah, the certificates. And wasn't that also the previous usage already of the blockchain?
Well, I mean, what's interesting about certificate transparency is the people who came up with it are like cryptographers, and they never once used the term blockchain.
Oh.
It's completely, it comes from a completely different place than anything in Bitcoin. Yet the solution they came up with is very similar. You know, the way they actually hash records is identical to a data structure I came up with a few months prior, which I call a Merkle mountain range, and they just call a Merkle tree.
So you call it Merkle Mountain Range?
Yes, because it's basically a type of Merkle tree where you add data to a particular web. Like, so basically our goal is with the Merkle Mountain Range to define very precisely how you hash a Merkle tree over a list of items where you can easily append to the end.
Mm-hmm.
And if you start off with one item, the commitment digest for the data structure is just a hashed item. And you add another one, we create an inner node that commits to the two leaves. And then the key thing is, well, as you add more items, you then create more, you build up perfect Merkle trees. So here, right, hash that inner node, hash that. And when you add another item, you will.
Yeah, it becomes a mountain.
Erase that. And now you have a perfect Merkle tree with, power of 2 number of items under it.
The B trees are kind of like the same, or not?
Yeah, B trees aren't meant to be Merkleized because they're designed to have more than one item under, like it's more than 2 items under the nodes, which is more performance if you're trying to optimize for locality. Whereas this optimizes for short proofs.
Yeah.
And
because a Merkle tree by definition only has 2 children.
Yes, yeah, every node has 2 children. Yeah. And what's nice about this is when you add a new item to it, the number of things you modify is minimized. So if I add one item to it, it's already in that state. All that we're doing, right? Adding one more inner node and then modifying that. Everything under one of the prime or on the power of 2 mountains stays the same. So once they're integrated into a power of 2, it's immutable.
So the operation of adding an extra Merkle node is also very not much. Doesn't cost a lot.
Yeah. Your proof of adding a new item will have about log 2 in data in it, because there's only ever going to be log 2 in mountain tips, so to speak, roughly speaking. Similarly, if you want to go modify something, like suppose I went and modified this entry here. I'll go mark that as spent as an example. That's the data you need to modify. And that can be done very efficiently.
Yeah, what I find so fascinating about it is that with those Merkle hash trees that you can prove that you have data which belongs to it, but you don't know what's in it. I mean, you don't know the total in it. You can only prove that it's in it. And you can prove it quite efficiently.
Yeah.
It's very fascinating.
Yeah, with this one, particularly because it has a deterministic commitment hash for any given state, you can do indexing, right? I can go say, prove to me that the second item in the tree is spent. Now there is a catch with this, though, which a lot of people won't realize. So I'll go draw this spread. So say, so if you're given this, if you tell me that the state of the tree is this top level hash, right, and you want to prove to me that this item here is saying state, spent, right? If you go, I would claim that if you give me this data, that's actually insufficient to go convince me that that's true. And this gets kind of a bit of nuance, like what these systems are actually proving. All right, so if you want to prove to me that this data was in the tree, right, I think we'd see how showing these commit hashes is sufficient to prove it was in the tree. But I would say it is not sufficient to prove where in the tree it was.
So you can prove it's in it, but not where.
Yes.
But is that?
But those intermediate steps sort of define where it is, doesn't it?
Well, so maybe we should be a little more precise. When we say where in the tree, we want it to be infeasible to have two different claims on that lead to different places in the tree, that are inconsistent with each other.
Well, there might not be a tree at all if you only provide that data.
Yeah.
That's the point.
Yeah. So that solution could be to make more blocks.
Yeah. Okay. So what Roy was saying, you as an outsider, you don't know what the whole tree. You don't know the state of the whole thing.
Yeah.
And that is the problem.
Yeah.
You don't know the size.
Yeah, because I was wondering why couldn't you use this for a blockchain?
Yeah.
It looks way more efficient.
Yeah. Well, so, and I'm not sure if this is the most optimal solution, but the easiest one I came up with was to have every inner node commit to the number of items underneath it. So here, for instance, I would commit to that there's 2 items under this node, 2, 2. That would commit to the fact that there's 4 items under that node, and finally 6 items. And the thing is, that commitment, as you follow it down, well, if I want to go find the item with index 0, well, obviously it's going to be in this part, right? And obviously it's going to be in that part, and then finally that part. You just add up as you go down the tree.
So then you would know about, let's say, the depth of the item.
The depth, or the position, really, right?
So in other words, you would have the example.
Well, it's like if this has 6 items under it, right? Then the index of those 6 is index 0 to index 5, all right? Well, if that has 4 items under and that's 2, well, the index is under this part, right? Would start at 4, and at 5. Whereas the index is under here would be 0, 0, 1, 2, 3. And you can just do that calculation as you go down and verifying that you're in the right part of the tree.
But the advantage would be that you, as the Merkle hash tree holder, still don't have to release the complete.
Yeah, you don't have to release a complete tree,
Yeah.
right? So it's very efficient to
But
prove
if you
these statements.
if you can prove that you are, let's say, being honest about the state of the tree.
Exactly.
How are you proving that it's in position 2 if you use it? So
Well, so this is the sum of number of elements under this node.
Yeah.
So if I'm starting here, and I know I'm looking for index number 2, or sorry, index number 1, right? The second item in the tree. Well, on this side, on the right side, obviously, every index under this part starts at 4, right? So index 4 and index 5. On this side, the indexes must be, because it's on the left, 0, 1, 2, and 3. So I know the part of the tree I have to descend to find index number 1 is on this side. And I can just do that calculation over and over again as I descend down the tree. Right, at every point, because I knew the number of possible items under that part, I know which direction down the tree you have to go to find the item. And it's impossible to lie with that, because there's only one possible side
But
for any given index.
But there could still be another. I mean, there can still be another fork. They can. I mean, yeah, there can also be another branch with the same depth at least.
But it would be in the wrong place, right? Like this is just committing to the number of items under.
Yeah, but I'm not so sure how you prove it's in position 2 and why it would not be in the first position.
Well, I'm saying if the statement is, I wish to prove to you that at index number 1 in the tree, the value you will find is this, right?
Yeah.
Starting from the top, there's only one possible path down to index number 1, right? Because at every step, you can rule out one of the 2 branches because it's at a range.
But I'm not so sure why it wouldn't have been in position 0.
But why? But
Well, no. I'm not saying that the data isn't in position 0. I'm just saying at position 1, the data you will find is this. The data might also be in 10 other positions, right? Like the statement is like, I have an array, right? The first item in the array will have this value. Maybe that value is copied to 10 other places, but at least at that position, the item has that value. This is an array, not a mapping. There's another type of data structure we'll answer, I think, what you're asking there, which is for this key, the value associated with it is something. And incidentally, Bitcoin's Merkle trees don't work this way, so you can't make that kind of statement.
They don't have the number basically.
Yeah, they don't have provable indexing. There's probably other ways to go prove indexing, but it's quite complex.
If it's a completely filled tree, then you don't really need those indexes, do you?
Yeah, in a perfect tree, you don't.
So this is only for when you have.
Yeah, the problem is you don't necessarily know that's going to be a perfect tree, right? And the logic to do that's quite a bit more involved. Whereas this, with very little data, can prove this in really trivial implementation. To be clear, I'm not claiming this is the only way to do this. I'm just claiming this is a very good way to do this. It's obviously correct.
Could you implement that with the blockchain and then have the different states of the same data
Yes.
in blocks?
For example, rather than having your blockchain be a linked list, your blockchain can be this data structure, which means that I can say, at block number 140, and give me the stuff in there.
Mm-hmm.
Similarly, if I want to prove to you that block 140 and block 120 are in the same tree, where you're now at state, say 160, it's very simple to go say, all right, starting from state 160, index back to 140 into 150, and notice how they're the things you expect them to get, which is exactly what our plain inspection case needs.
Mm-hmm.
Because Alice wants to know,
Yeah.
was her record in there? And it's very easy to just query down and show that it was where she expected it to be.
So the state change logic, the process, if you wish, you have to implement that in code.
Yeah.
And then you could use the blockchain to use that. The software could use the blockchain to enable insights in this.
Yeah. Maybe the right way to put it is, because it's a hash data structure,
Mm-hmm.
right, and you're taking all this data and hashing it together, it makes it infeasible to lie about the data, where the type of lie you're trying to lie about is that there are 2 separate things that are now inconsistent. For example, there's no way in this type of data structure for me to simultaneously say that the second inspection report for this day was a pass and also a fail.
In this data.
Yeah. Because if I try to say that, either one person or the other is going to get an inconsistent proof, provided that they both have detected the facts. Well, provided that I will give them the same starting point. Now, obviously, back to our plain inspection case, if I successfully convince you that the state of the system is X, and I convince him that the state of the system is Y, I can lie to both of you. But this makes it very easy for you to compare notes, because there's only one number you have to compare.
But I have to trust the protocol or program that shows me the results.
Yeah, but
that's
I mean,
that's not a problem.
it is a problem if you can't trust that, all bets are off.
Yeah, but you could always dive into the blockchain itself to to check what.
Well,
there
you
are
dive into the
pieces.
blockchain with source code, right?
Yeah.
If the programs that you use to inspect the blockchain are lying to you,
Yeah.
I mean, all bets are off.
Yeah,
Yeah.
of course.
I mean, it's kind of like a good analogy for this computer stuff is if I had the ability to give you a pair of glasses and I could control what you would see through those glasses such that you have no ability of ever detecting, that you're looking at something you don't think you are, that's sort of how bad computing is.
Yeah.
You really got to trust your computer and be able to inspect it.
Gets close to the matrix.
Yeah, that's basically anything I could go do.
Yeah, but you're just paranoid.
Not paranoid enough.
He's asking the right questions.
Yeah, because you're only using CubeSOS and not Gmail.
Yeah. I mean, this is, why we have deterministic builds as an example.
Yeah, you know what I actually, why I was so, Peter, why I was so happy to, felt enlightened, sounds a little bit, because now, because of Bitcoin, everybody wants to have a blockchain and everything.
Yeah.
But what I liked about the reproducible builds is that to have a blockchain and everything is a superficial way of thinking, hey, Bitcoin is doing something well, let's take it and we copy it, while reproducible builds is doing what Bitcoin actually really does, and that is distributing the trust.
Yeah.
And that is the copying of the success of Bitcoin in a good way.
Well, so reproducible builds are an interesting example because we could apply this whole same plain inspection game to reproducible builds problem.
Mm-hmm.
I, as Debian, would say that the root hash of all packages in this distribution was this. And then you can go challenge that by saying, all right, I'm going to do a reproducible build of, package number 10, package number 20, package number 50, 75, 80, repeatedly.
Mm-hmm.
And the more I challenge that, the lower the chance of me getting away with fraudulent packages, right? If 10% of the packages, the build fails, I don't have to try that many times to detect, well, hang on, packages aren't actually building correctly. Yet I don't have to check every single one. Like any auditing thing, but this makes it, this kind of scheme makes it very hard to lie about that because I'm telling the rest of the world, that's the route you start off, that's where all records are under.
Yeah, you mean you have kind of like the same advantage as when building a Merkle tree, that you are building on your previous giant shoulders.
Yeah.
Okay.
And I'll show, so this type of tree happens to work well if you've, indexed data, right? First item, second item, and so on. The other main type of tree you can use is a key value mapping. And the type I wrote up in my proof chains work, I came up with the name Rabbiner tree because I needed a name for it. And if you're familiar with radix trees, that's the same kind of idea, where an empty tree, right, just has one node. And when we add an item to the node, what we do is we go take the key and figure, when we add one item to node, we go say that, here, let's draw this right. So there's your empty tree, right? So it has an empty node, a special symbol just saying there's nothing in this tree. When we add something to the tree, we now have your leaf node, and that's your value, and that's your key. So it's mapping key to value. And if there's only one item in it, when I hash this, well, I know that that's the value and that's a key. Very simple. When we add two things to it, let's go draw this here. Key 1, I'll say that's value 1. And now we have key 2, value 2. And now we're going to need an inner node to connect to the 2. And we can determine, we can identify the inner node by saying, well, when I hash these two keys, what is the longest common prefix of bits. And I'll suppose this key is 1110111. All right, so say that's key 1 equals key 2 equals 1111011. Well, yeah, these first two are identical. And then in our inner node, we will then say that's prefix 111. And if the next bit is 0, you go on this side. If the next bit is 1, you go on this side. You just keep building that up. And if I add another item, K3, and I'll say that's 0, 1, 1. Well, that's a 0. So now there's, no common prefix in my K3. 3 will go here.
Are you describing a sorting algorithm here? Something like that.
You're the hashing algorithm, right? For these 3 items, what hash will we get? We can calculate that hash by essentially, kind of like sorting the items into the common prefixes. Yeah. And this is a very simple algorithm. When I go and say add another item, 0, 0, 1, et cetera. Oh, erase that. Make a new inner node with that common prefix is just 0, and so on. K4. You just keep on adding items. And again, starting from, if I want to say, what is item starting with, with key whatever, well, because I know what prefixes are, I can easily just send down the tree and I'll always get the same result. And if I want to go and prove to you that there is no item in the tree, for instance, starting with 1, 1, right? Say it's all ones. All right, that's the prefix. And the 1, hang on a second, it's the wrong item. And there's my data. Prove that this doesn't exist. Pretty simple stuff. You can imagine in our spectrum reports example, if our keys are Alice, Bob, Charlie, etc., all the inspectors, it makes it very easy to go determine, well, what reports were made by what people and get the full set. Full implementation, this is up in my proof chains work, but between those two structures, there really aren't that many things we've really seen the need for these applications.
So what was your name for these trees? Jim?
This I call a Merbiner tree, and that term I use for this exact method of having prefixes and so on. I needed a term rather than calling it like yet another type of word.
Bitter tree?
Merbiner. MERBINNER.
MERBINNER.
Just
Yeah.
Does it mean
That's
anything?
what a pen.
No. Well, so a lot of people call these Merkle radix trees, but when someone says Merkle radix tree, they don't say which type, right? Because there's tons of different ways to do this, and they all have advantages and disadvantages. But unless you start coming up with names for things, it just gets very confusing. So I picked something and kind of sounds like more binary radix tree, I guess.
Yeah, I saw
all ears.
that you are not good at such.
Yes,
Come on, separate it.
The Merkle mountain range one is because when you draw it out, it looks like a bunch of mountains. That's the limit of my very careful thinking of names.
Very visual.
Yeah.
Focused.
Yeah, it's not that easy to. I could have called it Todd tree, but that'd be. And after all, which one was Todd tree? Yeah, cool.
Okay.
But have you already heard that Bitcoin is doomed?
Oh, it is doomed.
Again?
Again. Didn't I already say, like in the long run, the sun explodes and we all die?
That the end is near.
It's near.
I can say with absolute certainty that Bitcoin is doomed between now and I think about 3 billion years in the future. It's certainly going to die between then. And if it doesn't, I won't be around to find out my bet was wrong.
No, the news about Coinbase going to Ethereum or something like that. Yeah, the point is I didn't read the whole story, so maybe I'm copying bullshit.
They're adding Ethereum to their exchange. They're changing the name to DJX or something digital.
GDAX, yeah.
DJX or something global digital asset.
So next year they will have a new name again.
Maybe.
Yeah.
But they try to make it more generic than Coinbase. No, it's global digital asset exchange.
Well, I mean, some people would say that's a good thing, and that means Coinbase is out of our hair.
Yeah,
So yeah, because now we don't have the confusion. You mean?
yeah.
I mean, just Coinbase's demands on the Bitcoin team are things that we aren't going to do, so.
What do you mean? Do they expect
Change.
Oh, yeah, they expect block size to just grow indefinitely.
Oh, yeah. Oh, sorry. Yeah. No, I thought you meant something about the name, the technical name.
Yeah, no, I just mean like their expectations for.
Yeah, but in my opinion, they're complete idiots. The guys. You know,
Yeah.
I mean, I forgot who I was talking to about it, but I mean the block size increase. I mean, yeah.
I mean, my suspicion is they're not complete idiots. It's just what they want out of Bitcoin is different than what we want.
Mhm.
You know, they're
They're
highly
in
regulated.
general the people who want
I mean, keep in mind,
unlimited,
they're a highly regulated
Mhm.
company.
Mhm.
They don't need Bitcoin to be censorship resistant.
Mhm.
Their company isn't censorship resistant.
Yeah.
You know, if you go and like pay someone who goes and then sends the money to a poker site, you're going to get your account frozen. That's not really the sort of Bitcoin I'm trying to work on.
Mhm.
I mean, it's sort of Bitcoin they can do in the U.S. in the highly regulated environments, but you know, given they already have that problem, what would they care if Bitcoin miners started censoring transactions?
I was actually thinking, is there now we're at it. Most of the reasons for the block size increase were, in my opinion, kind of ridiculous. But there was actually one reason I do like. Also, I still think it's not a valid reason. A friend of us, he is very pro unlimited block size increase, and his reasoning was that everything should be a hard fork because people should be forced to choose.
Yeah.
And in itself, I like that, but I don't think you can expect. I mean, from devs, you could expect to have the knowledge for that. But I don't think you can expect it from, everyday people using Bitcoin.
I personally, I think it would be much better if soft forks weren't possible.
Mhm.
But weren't. But with the current design of Bitcoin, we can't get rid of them.
Mhm.
There's no way to prevent miners from not mining transactions that they choose not to.
Mhm.
So, as long as that's true, soft forks are possible.
So to say it like that, in that view, you agree with the reasoning.
I agree with the reasoning, but I don't think it's possible.
Yeah.
I mean, it's like, I agree with the reasoning that we should have world peace.
Yeah.
It's not a very useful statement.
Yeah.
Why is it not possible?
Well, because all a soft fork is that miners
No
choose.
world peace.
No.
No, a soft fork just means that miners choose not to mine transactions. Like, we can't force miners to mine all transactions.
So it's kind of like censorship. They are able to censor.
Like, the closest thing you can get to that is ideas like my tree chains concepts, where all validation happens client side.
Mhm.
But I mean, that's so far away
Yeah,
from the current design of
If
Bitcoin.
you wouldn't have specialized miners.
No, it's not about specialized miner. I mean, you could implement this idea with ASICs, right?
Mhm.
But the point is that in a tree chains concept, when I go pay you, I would give you proof that the transaction is valid. Miners wouldn't see most of that data. And in that,
Hash basically, they don't validate anything.
yeah, I mean, miners essentially just process a small amount of data that they don't that has no meaning without other data. And in that model, well, you know, technically miners can still do soft fork, but it's not really feasible for them because they don't know what they're soft forking out. But that is so far from what Bitcoin is right now that, you know, if that gets implemented, it'll probably be implemented in like 2 or 3 years, if not more. So it's just, I mean, it's not a reasonable response to that criticism. For all practical purposes, tree change is vaporware right now, so it'll be a long time before you can make it real.
But as a way of upgrading, you are sort of pro soft fork then, right?
Yeah, I mean, given they exist
Yeah.
for uncontroversial upgrades, they're definitely the safest way to do them.
Yeah.
You know, if we did a hard fork for everything, I mean, every time you want to change something, we'd be creating a new currency.
Yeah.
That's by itself should make you worry.
Yeah, on the other hand, it seems that at a relatively early stage of Bitcoin development, you're already sort of having all these backward compatibility issues, because that's basically what it is.
But the
Yeah,
protocol,
so it forces you to stay within the limitations that were maybe.
but the thing is, the protocol was, you know, either by luck or by design, very well suited to do backward change, you know, backward compatible changes. And equally, I mean, even when you look at big managed systems.
Yeah, but even the things we looked at yesterday, where you had this segregated witness stuff, and
That-
then
yeah, you realize that
you
is-
have to put the roots,
Yeah.
let's put the roots
But-
of the tree in the.
But you
Coinbase
realize that
transaction.
is the worst example we have. And even that is not that many more lines of code to do the
No,
backwards
but it's
compatible
more like you're putting the root of the witness tree, you
Yeah.
put it in the Coinbase because there's some space we can use that.
Yeah.
I mean,
But I mean,
if you were free to design it, you would probably have done it differently.
yeah, but again, the difference between the clean sheet design and the design that we're going to end up going with is a couple lines of code. It's not a big difference. It's
No, but I understand that, but it's more about what builds up over time.
yeah, but my point is that because the protocol is designed in a way that allows for backwards compatibility, those kind of so-called hacks, there's not very many that are needed. You know, as an example, with my own check block on verify opcode, implementing that in a software compatible way versus a non-software compatible way is about 1 line of code change. In fact, to be exact, it's 1 line less of code, because there's one thing that you don't do that you would do for the hard fork version. And I mean, the difference is trivial. There's really no reason to worry about it.
But what do you think about endpoint blocking the what do you call it? The segment. And then it's like 40% of the current hash rate, and they do not enforce the Bitcoin Core includes hard fork.
Think of it this way.
Unactivated hard
If
fork.
SegWit gets fully released and then don't block it, what they're doing is preventing an upgrade for their own petty political reasons.
Yeah, no, I know. But
I mean, they're welcome to go face the Bitcoin community.
all right, but that's one question. But the question 2 is more like, what do you think about 90% of all the hashing power sitting there at Hong Kong?
The number.
I'm not sure if that's
It's a-
correct,
it's a
but just
yeah, it's a
saying that
pyramid
it's
lab.
already really centralized.
It's a very complex thing because
I know, but I just.
like the question is, what would happen if that hashing power was used for evil, so to speak? And for example, I mean, you can imagine some hacker hacks into ant pool and F2 pool, and that by itself would be enough to reverse large numbers of transactions. My guess is the response to that kind of hack would be people freak out and they point their hashing power to the pools. Because F2 pool, as an example, doesn't own any
Just
of
like
the
with gigahash,
yeah, I mean, F2 pool doesn't own any of the equipment pointed at them.
the ghash that they remember.
Yeah.
It's like
Yeah.
52% of people
Yeah.
were pointing to
Yeah.
other places.
And, you know, I mean, it's hard to know for sure, but it sounds like most of the hashing power, actual physical hashing power, is owned by a fairly widely distributed group of people, and it's widely distributed physically. You know, basically because, I mean, there's only so much free power you can get at any one place. You know, most of this is like stranded hydro. In
Yeah, but
weird
then
places.
again, I always, with that discussion, I always think, I mean, I'm not going to justify 51% hash power, but I mean, those people are putting their electricity on risk. And again, if things are really getting nasty, people could power up their own, hash power.
Not feasible. Equipment just isn't available. Like if I wanted to get, even if I had unlimited money, to get another 25% of the network's hashing power tomorrow, there's no way I could do it.
Yeah, okay, but I mean,
the equipment just doesn't exist.
Okay, but what I mean is that I wouldn't be surprised that in the end, you will always have a balancing of, I think the hashing power will always tend to not together.
Well, see, the thing is, there's very valid physical and economic reasons why the physical location of hashing power will be somewhat decentralized. And the reason is simple. Getting free power is a lot easier to do on a small scale than it is on a bigger scale.
Okay.
You know, because as you have a bigger and bigger scale, your opportunities to do something valuable with that power increase. You know, there's enough money available to build a transmission line, for instance, to somewhere where we could sell it at a higher price. Whereas the opportunities for Bitcoin hashing are at smaller scales. Things like, you know, as an example, in China, you have a lot of hydroelectricity plants that were just built in the middle of nowhere by the communist government like 30 and 40 years ago. Yeah, and that power is at below market prices because it just can't be sold. There's no transmission lines.
It's even better. They build complete cities with no citizens.
But that's not actually like where this power is coming from. It's mainly, you know, renewable energy just in places where you can't sell it.
Okay.
Right?
But electricity prices recently went negative in Germany and in Portugal.
Well, I mean, but again, I mean, that's
paid for mining.
Yeah, but again, I mean, that's another example where decentralization is encouraged by the fundamental incentives. Like the reason why power goes negative is not because there's a surplus over a huge area. It's because there's a surplus of power in specific areas.
Yeah.
You know, that those kind of opportunities only exist in certain places and only for a certain amount of power.
Yeah.
You know, it's not like there'll ever be, I can go and get negative power for gigawatts worth of power. That just doesn't happen. You know, similarly, like, well, what do you do with waste heat? If you have a little bit of waste heat, it's pretty easy to get rid of. If you have gigawatts worth of waste heat, there's nothing useful you can do with it. So it costs you a lot more money to get rid of that heat on a large scale than a small scale.
Start your own somehow. So
yeah. I mean, there's a limit to like how much dried fruit you can make in any one place.
But yeah, don't you think like Bitcoin already exists for 6 years now, and you can see it already really centralizing with the mining.
Well, that's not true.
It's not true because
it's not as bad as people think it is. Right? Remember, there's 3 different things going on here: the production of ASIC equipment, actually running the equipment, and then also pools.
Because it's almost like saying that Bitcoin is fully centralized because there's only one blockchain.
Yeah.
Yeah. So it's like you have one mining pool. And so if every miner would work for one mining pool, it would be 100% of the mining. Yeah, the mining pool would have 100% of the mining power.
Well,
but there's still all these individual miners.
So between those 3 categories, right? The production of ASIC equipment is hopelessly centralized. And the entire world's economy seems to be unable to support more than like 2 or 3 companies with top-of-the-line chip fabs. You know, that's never going to get any better until like we have biological computers or some, you know, massive technological change. Designing the equipment is at least fairly easy because it's something, you know, a small team can go do.
Yeah.
It's just that actually producing the chips is very expensive, very high upfront costs.
Yeah, but what I also...
hang on. So running the equipment is inherently decentralized to an extent because cheap electricity and cheap ways to get rid of power just don't exist in large scale. So you kind of get this bathtub curve. Like if I'm going to run, you know, 0 hashes per second, my price per hash is infinite. It kind of quickly goes down. There's some plateau of the cheapest possible way of doing Bitcoin hashing, then gradually gets more expensive at the other end. And then finally pools, well, the underlying incentives in Bitcoin is this sort of slope where you are most efficient at the biggest possible pool. And the bigger that slope is, the more screwed we are in terms of centralization. You know, larger blocks make that slope higher. And the fact of the matter is, if you're on F2 pool, in theory, you're earning more money per hash than if you are solo mining because of orphan rates. Fortunately, the difference isn't very much right now. But you know, when you double the block size, that difference essentially doubles, if not even more. So.
Okay, so the reasoning, because people are often saying you can't solo mine anymore, but that is right in the sense that there is not a relative equal chance for you to find. And so if you have one amount of hash power and the other has 10 amounts, the one with 10 amounts not only has 10 chances more, but because of the orphan rates, even more.
Like if every block was 1 byte and the internet was infinitely fast with 0 latency, there'd be no difference.
Mm-hmm.
But because of latency and because of block size, there is a difference, and you earn less money. The difference is still small, like it's on the order of, say, percentage point or 2. But percentage point on a revenue of like 10, profit margin like 10% is a pretty big deal. And it just gets worse and worse as the block size increases. It also gets worse if someone's trying to attack you. If you're mining like transactions people want censored, I'll start DOS attacking you, for instance.
Mm-hmm.
And now your bandwidth needs, or your ability to get bandwidth goes down. You might have to be over Tor or something, which is quite slow compared to, say, the fastest fiber links you might be able to afford. And there's just no good solution to this other than keeping block sizes small.
But you don't take the really big loads. Loads. Hull?
Yeah.
The hulls filled with a lot of mining equipment, all the shipping containers filled with mining equipment will not tend to grow bigger because the amount of energy required for that is just not very
that's
available.
the thing. The cost per unit of hashing power, the cost per like gigahash per second goes up if you have more hashing power in one place.
Why do we have 20 power stations in the Netherlands?
Yeah.
Why not plus 1?
Yeah.
Because you have problems. You have problems with distribution of electricity. You have problems with heat generation. Where you're going to get your cooling water.
You don't see if it goes down.
Yeah. So but there are some limits, like you said. There's some limits. Where do you get? What do you do with all the heat? You need
Like
cooling water. You need.
So there's a kind of like an optimum.
Yeah, that's what he said. So you have this optimum, and then it goes worse again. So you have a sort of maximum optimal size of a mining operation, because otherwise.
So in other words, what you are saying is that the scalability of ASIC data centers should be increased. Yeah.
Well, I mean, we're already seeing that. People don't put all the hashing power in one place. I mean, that's just the truth of it.
But
they put it all at the same
It's
pool.
the same as this power station. The typical power station is between like 600 and 800 megawatts. Because that's sort of the optimal economic size for a power station. If you try to make it bigger, you run into trouble. You run into trouble with your transmission lines. You run into trouble with your cooling.
And like currently, the biggest installation of hashing power right now are on the order of like 1 to, I think maybe the most is like 5 or 10 megawatts.
Yeah.
Bigger than that, I mean, just nobody has a source of cheap power.
It's the same with cloud data.
And for instance, even like that 1 megawatt, 10 megawatt facility. If I'm in my dorm room stealing power, I'm getting power for cheaper than they ever will. Or if I'm using power to go heat my water heater, again, I'm getting free power and they're not.
But it is sort of the same as data centers. Cloud data centers, you can't make them ultimately large.
The key thing that it isn't the same though is that the supply of ASIC hashing hardware is not easy to get right now because the manufacturers of it. I mean, interestingly, a big part of the reason why it's hard to get is how do you make the most efficient possible ASIC? You cut corners. You make a piece of equipment that if you don't put the fan on it in just the right way, it'll like explode in flames. And that's actually not even a joke. I mean, they really do catch fire because they're just so unreliable. This isn't equipment you can sell to consumers. It's too unreliable to get away with it because you're going to get returns from people who don't know what to do it.
It's one of the reasons why consumers can hardly buy them anymore because providers don't want to even bother with consumers. They're going to be complaining.
So if I have a dorm room with cheap power, I just can't participate anyway because no one will sell me a hashing unit.
But do you think that sort of should become better over time right now? Right? Because the big changes in nanometers and stuff are sort of over now. So.
I mean, ASIC boost is a good example of how it might not get better because you could easily get a monopoly where some people who are creating the equipment try to shut other people out of the market. And if you're creating the equipment and also running it, it's in your incentive to make sure no one else can go and buy it and be competitors to you. Essentially, if we had the ability to have proof of work that could be run on standard computers, this would go away. But nobody knows how to actually do that.
It came from the centralization idea when you started this discussion about examples like manufacturers of chips, of course, hashing power per kilowatt hour, and pools that set back the sole miners. And that's because of latency and block size increases and DDoS attacks. They might suffer.
And I'll point out, of those three, I am actually least worried about pools.
All right.
Because if pools are easy to start, the moment one pool does something bad, it's very easy to start another one and people can put their hashing power out. It's not great to have to do this, but it's of those like risks, that's the one I'm least worried about.
I was just wondering when I saw the image saying 90% of all hashing power sitting here just at the conference.
Yeah, that's not. Well, I mean, for starters, one of the guys at that, it turns out he was lying about how much hashing power.
Yeah.
Marshall Long was just a scammer. He actually took me some installation in China. And it was very interesting because before we went there, he said he owned all the equipment.
Okay.
And I'm walking around thinking, that's funny. Why does it sound like he's in a business negotiation with people who he claims run this stuff? And he claims he owns the equipment. This doesn't sound like this should be happening. Asked around again, of course, sure enough, he had like one tiny rack of equipment in the corner somewhere, and the rest was other people's stuff.
But were you also in that video which was released on April the 1st?
Oh yeah. I mean, that's how most hashing is done.
Yeah,
Shovels, pickaxes.
Yeah.
I did a bit of that mining myself.
It was a funny video.
Oh, completely accurate too, I should say. Child labor in Bitcoin mines is being
Centralization pressure.
I heard that hoe noem je dat nou? Zwangsel? Yeah. It isn't. And I wanted to say I heard that they were looking for Bitcoin whiz kids at the very young age. So start from on the number. But this kind of covered the storing data on the blockchain, but also a little bit your ASIC boost, if I'm right.
Yeah. Well, maybe that's related, but another step, I guess.
I mean, if you still want to store data on the blockchain, there are better ways to do it.
So if you want to do a break.
Let's have a break.
Less of a coffee
If we're
break.
not happy with the question, with the answers.
Yeah. Very happy with the discussion.
I like it very much that you come up with so many questions, and that's that's good because we filter our own business cases first, whether it's feasible for any blockchain application.
No, but for me, I think it's the most. I mean, the technical details and the questions, and okay, maybe some things can be done, maybe, but it's the questions to us. Do we need it? Why are we using it? I don't know, better solution. I think those are for me the important sort of questions from a solution architect kind of idea.
Yeah.
Why use this and why not use that? And you need to have a clear idea why you to use blockchain if you are going to do it. And I don't think a lot of people don't have a clear idea why they just use blockchain because it's the latest new fashion.
But I think you have to realize that the using of the word blockchain was actually to not say Bitcoin.
Yeah.
And it seems like a joke I'm saying it, but why I'm saying it is that the reproducible builds, the Gideon building, that's a good example of how you should copy the Bitcoin model. Yeah. But simply simply copying some oppervlakkig, superficial is that?
Yeah.
Yeah, simply copying some small element of a successful technology shows that you don't understand what the technology is really about.
Well, I mean, we call it cargo culting.
Was it?
The cargo cult. You know, so it dates back to like apparently in World War II in a lot of Pacific Islands, the people who lived there would go see these planes go land, and all these supplies come out of the planes. Thought, oh, that's great. So if I want planes to land and get all this free stuff, all I got to do is build a runway.
Oh.
And then go build runways supposedly and set up aircraft, control towers and stuff. And mysteriously, the planes never landed.
Oh. Okay.
How's this word? How do you spell it?
Cargo cult.
Cargo.
Yeah, as in a cult of plane cargo.
Cargo cult.
Yeah. Refers to when you go copy something, but you're missing something very essential.
All right.
And by the way, now we're talking about it, it's kind of in the length. SIA coin. I heard you said something like you liked something of the idea of SIA coin. What exactly? Yeah, maybe
the goals are nice. Like it's
for other. Oh yeah, sorry. Yeah. Sorry. Sorry.
Right now, I'll get on record.
I'll remember the question.
I want. Oh yeah.
I knew it.